They try to write books, so the stuff you need to get through for sure, you probably have in the first 8, 9 chapters. If you can get to 10, 11, 12, that's great. Basically what this is it's kind of intro into algebra. So whatever you can glean from these next few sections we get through before the end of the school year is going to make algebra go better. Because pretty much every algebra book I've seen, even my Algebra 2 book, kind of starts out with functions. What's a function, and how do you tell functions, and domains, and ranges, and that kind of stuff. So whatever you can glean from here will make the beginning of next year just be that much more exciting and fun for you, or at least easy. So chapter 10.1 is all about functions. So a function is a relationship. Basically, you have two variables, an x and a y. So it's a relationship, a connection between x and y, where each input value, they call it. Do you agree usually we put numbers in for x and find y? Mm-hmm. So each input or each x value has only one. I'm going to put that in caps because that's important. Only one output or only one y value. In other words, we're looking at what are equations, what are graphs, what are data tables, where each x value can only be paired with one y value. And when that's the case, you have a function. And that's the key. Each x can only have one y. One y could have multiple x's, but each x can only have one y. So it seems tougher than it is, perhaps. But if we were to go and look at some of these, if we were to do y equals 3x plus 2, I'm just going to do a quick little graph of that. But you could take and make a data table either with a graphing calculator or on a piece of paper. But that's going to be a line. I don't remember what we did already this year. The 3 and the 2, does anybody remember what the 3 and the 2 stand for? Did we do that with you guys, or am I confusing you in algebra? Okay. Well, if we were to do that, maybe you could either look at it graph-wise. Yeah, so maybe you have it, maybe you don't. But if we were to look at that, do you agree if you put a 1 in for x? So I'm going to get 3 times 1. I don't know if I'd bother writing this, but 3 times 1 plus 2, I get 3 plus 2, I get 5. Do you agree? When I put a 1 in for x, there's no way to get something other than 5 for y. And that's going to be true no matter what you put in for x. If you put in one number for x, you're only going to possibly get one output. So is this a function? Yup, it's a function. So function, check. If you were to try to graph that thing, I don't know if this is worth doing. I thought maybe you'd jump right out of the gate at it. But that here, the y, or the 2 is going to be the y-intercept, and the 3 is the slope. That's what I was kind of looking for. So if we were to take and graph this, it's going to be something like this here. So if you have like a straight line through here. So each spot on this x-axis is going to go up and just have one y value. So any x, this x go down here has a negative y. This x has a y value of 2. This x has a y value of 0. So you don't have to draw it, but that's just kind of what's going on for the things. Okay, this next one. If we're looking at this data table here, does each x have only one y? No. Because when x is 3, do you agree you get 2 different y values? So when x is 3, sometimes y is 3. When x is 3, sometimes y is 4. So this one here is not a function. And if you think you're going to look at that later and be like, why? You could say when x equals 3, comma, y equals 3 and 4. Well, you have 2 different y values for that one x value. Yes? So try coming up with another situation. If you have a buy 3, the 4th one is free. Buy 3 donuts, you get a 4th one for free. So this wouldn't really fit for donuts. They're expensive donuts. But okay, so you buy 1 donut, costs you $3. 2 donuts is 6. 3 donuts is 9. 4 donuts is still 9. Yeah, okay. 5 donuts is 12. Is it a function, not a function?
No function.
It's tempting to say no, but because it's weird, a lot of times people equate weird with like not a function. But if you go back to our definition, does each x value have only one y? Yup. Because when x is 1, here's your y value. There's not 2 costs for buying 1 donut. So this one here is a function. So function, check. Each x has only one y. You'd have to have another place where you have like a 5.15 or something like that. That 5 donuts cost $12 and 5 cost $15. Then it wouldn't be a function. But ready for example 4? Babysitting. You charge them $8 an hour because they're a poor teacher or something. I don't know what you charge for babysitting, but my wife handles that. So 1 hour, you get $8. 2 hours, 16. 3 hours, 24. 4 hours, 32. Function, not a function? Function. Because for each x, there's only one possible y value. So function, check. Each x has only one y. And now last question, it's not a function or not a function, but if they were to say, if you were paid $67, going back to this example here, how long did you work? So we have this equation here, P equals 8 times H. Where do I put my 67? P, yep, it's the pay. So you get paid $67. So 67 equals 8 times H. So to find how many hours you worked, we would divide both sides by 8. That drops out and just leaves us H, and then gets us 13. So 13. Or maybe not 13. What does that give us? Anybody?
8.375.
Oh, hey, let's go with that. 8.375?
Yeah.
Thank you. The 13 sounded wrong, but I'm not feeling the greatest today. I just looked at my notes. So, all right, we good? So that's the section.